What we're working on in this video is learning how to divide radical expressions. Now, the reason why I group these problems like this and this is that this and this are the same problem. This and this are the same problem. See, we have this property when we have radicals, is that when we have a radical and a division, we can break these up separately by taking the radical of the numerator and the radical of a denominator. Now, when we look at this, okay, this problem and this problem are exactly the same. So let me start with this, because this is one step beyond. So we're going to go 6 over 4 square root of 24 over square root of 50. Now, the way to think about this problem, whenever we deal with radicals, the outside interacts with the outside and the inside interacts with the inside. The outside and inside don't interact with each other. So really, this is two separate problems. You have 6 divided by 4, and then you have the square root of 24 divided by 50. And the first thing we want to do is simplify the outside and then simplify the inside. So when I simplify this, just as a fraction, we get 3 over 2. And then when I simplify this, we get 12 over 25. Now, so initially these are separated. What I want to do is combine the radical, simplify the inside, and then what I want to do is separate them again. Okay. Once I've separated them, I want to simplify them individually. So if I ask myself what perfect square divides into 12, well, square root of 4, right, square root of 4, 4 times 3 turns into 12. Then over here on the bottom, the square root of 25 is 5. So now we free it from inside the radical, it's now on the outside. So now all three of these numbers interact. I have 3, divided by 10, and the square root of 4 is 2. Now I have square root of 3, so this turns into 6 square root of 3 over 10. Now remember, this can also simplify once more. So it's a little confusing. So the first thing you want to do is you want to combine the radical, simplify the inside. And then what you want to do is simplify everything on the, simplify the radicals, and then that may pull numbers out. And then you may have to simplify that number on the outside one more time. Okay, so let's do the same thing over here. This is, let's look at what we do when we have variables. So let's start with this one, because this one's slightly harder. Now the first thing I want to do is I want to combine them. Okay. Now, what we want to do is simplify the inside. Okay. Now let's deal with simplifying this variable. My index is 3, so I can remove the variable from the radical by dividing by the index. Now I'm going to do something a little bit non-standard. I'm going to look at this and say 3 goes into 11 3 times with a remainder of 2. All right, so I'm going to write something non-standard. Now this is the exponent that goes on the outside of my radical, and this is the exponent that goes in the inside of my radical. So let me just do that. I have y cubed and the cube root of y squared. And then we'd be done. Now if you're wondering why does this step work, if I have y to the 11, okay, so if we go from here to here, we have 11 y's. 1, 2, 3, 1, 2, 3, 1, 2, 3, then 1, 2. Right? We have a group of 3 here, a group of 3 here, a group of 3 here, and a group of 2 there. And we can think of this like cube root of y cubed, cube root of y cubed, cube root of y cubed, and then cube root of y squared. Now, each one of these, right, since this index is equal to this exponent, this just turns into a y. This just turned into a y. This one just turns into a y. And what we're missing over here, it doesn't have enough y's to pull it out of the radical, so this remains on the inside. So we have y cubed, cube root y squared. Now, this is messy. What I just would rather do is just divide 11 by 3, and then this number will tell me how many y's I can pull out, because I have 3 of these, and how many remain on the inside. Okay, so now let's put this all together. This looks pretty nasty. We can just start from here, but just know that if we started with 2 radicals, we can combine them. So now let's first simplify the inside. Now 81 and 64, there's nothing to simplify. But if I have 9 of these x's on top and I get rid of 2 of them, I should have 7. And over here, we have more y's on the bottom. So if I have 8 y's on the bottom and I get rid of 2 of them, I should have this. Now, we can break these up into component parts. We can say 81 square root of x to the 7 over square root of 64 square root of y to the 6. Now these square root just like we want them to. And then when the index is not written, the index is assumed to be 2. So we're going to have x7 divided by 2, y to the 6 divided by 2. And then we get 9x cubed, remainder 1, 8y cubed. Now this tells me how many are on the outside, and this tells me how many are on the inside of the radical. So I should get 9x cubed square root of x over 8y cubed. Now let's work on this problem that's on the right side. The difference between the problem on the left and the problem on the right is the problem on the left had an index of a 2, and the problem on the right has index 3. So we're going to start the same way, where let's start from over here. But if we had this, this would then turn into this. Okay, now what we want to do is simplify the inside. So the beginning will start out the same, and we will get 81 over 64. Nothing simplifies. X to the 7, y to the 6. Now notice that this and this are exactly the same. The only difference is we have a index of 3 over here and an index of 2 over here. So when we're dealing with an index of 3, what we want to do is look at the prime factors. So 81 is equal to 9 times 9, 3 times 3, 3 times 3, and 64 is equal to 8 times 8, 2 times 4, 2 times 4, and then 2, 2, 2, 2. So this, these, and then over here, this is equal to this. Okay. So what will happen is that we'll get cube root of 81, which is 3 times 3 times 3 times 3. And then we'll get the cube root of 64, which is 6 2s, 1, 2, 3, 4, 5, 6. And then we'll get cube root of x to the 7, and then the cube root of y to the 6. Now, if you've taken my class before, what you know is that if I have 3 of these, I'm looking for a group of 3 because that's what my index is. If this was 4, I'd be looking for a group of 4. So these 3 on the inside turn into 3 on the outside. So over here, I'm looking for a group of 3, right? 3 2s, 3 2s. And the way you can look at this is that the top part is equal to 3 cubed with 1 3 left over. Do you see how I have this is here, this is there? On the bottom, I have 2 cubed, and then we have x to the 7 divided by the index, and y to the 6 divided by the index. Now, when the index and the exponent are the same, they cancel each other out. So this just turns into 3. Same over here, when the index is equal to the exponent, you can just pull that out. And same thing here also. Right? This index cancels out that exponent because of the same. Now the problem over here is I don't have a cube here, so I still have 1 3 left in that radical. Now, if you were taking my class, we would go directly from here to here. These 3 on the inside turn into 1 3 on the outside. These 2 on the inside would turn into 1 2 on the outside, and so on. And for those of you who are just meeting me on YouTube, I'll put a link to my video on how to simplify radicals that sort of goes into how to do this efficiently. Okay, now this over here turns into x 3 remainder, I'm sorry, 2 remainder 1, so that's a 2, and this over here turns into a y squared. Now let's put it all together. In terms of the outside, this is equal to 3 to the 4. I have 2 y's on the outside, on the bottom, 2 x's on the top, and then over here, I have 3x with the exponent of 1, and we don't have to write it, and we're done. Okay. Now, what we have left are some boutique problems. Now, in the previous problems, everything was separated by a multiplication. So if we look at something like what we just did, everything here is separated by a multiplication. That's why we can simplify. Okay. Now, the problem over here is that I can't simplify the 6 and the 4 because it's separated by a addition. If this was a multiplication, then I could simplify it. But since that's an addition or a subtraction, you can't. So what you need to do is first simplify the radical. So if I say what perfect square divides into 12, I would get 6 plus square root of 4 square root of 3 divided by 4. Then I get 6 plus 2 square root of 3 divided by 4. Now there's 2 ways to attack this problem. Let me show you the way that my students generally don't like. And then I'll show you the way my students generally do like. So on top, the first thing I want to do is pull out a GCF. What number divides into 6 and 2? Well, that would be a 2. Okay, and I wrote the 4 here just so you could see that this right here, treat it like a fraction. This would turn into 1/2 if you were to simplify it. And then this would turn into 3 plus square root of 3 divided by 2. That's one way to attack it. The way my students generally like to solve this problem, or simplify this problem, is to say, what number divides into 6, 2, and 4? And that would be 2. So what we're doing essentially is we're multiplying the top by 1/2 and the bottom by 1/2, right? And we'll get 3 plus square root of 3 divided by 2. And my students generally like it because it's cleaner. Now, you can only do this if all 3 numbers have a common factor. So, for example, if I had something like this, even though the 6 and 2 can simplify with each other, the 5 and 2 cannot. So that would be your final answer if you're doing something like this. This only works if all the terms are divisible by the same number. Okay. So let's try it again over here. So let's simplify this first. So we get 9 minus 4. And if I look at the perfect squares that divide into 18, 9 does. So we get 9 minus 4 times 3 squared root of 2 divided by 12. That's 9 minus 12 squared root of 2 divided by 12. And if I ask you what number divides into 9, 12, and 12, we're only looking at the numbers on the outside. That would be 3. So you would get 3 minus 4 square root of 2 divided by 4. And then we'd have to stop here. Even though these two 4s divide into each other, the 3 doesn't divide into the 4. Every term has to be divisible by the same factor in order for us to simplify. Well, I hope you liked this video. If it was helpful, please like and subscribe so other students can find it. Thank you.